Natural law 2. The only constant is change, and human understandings are always in transition. There is no evidence to support the idea that anything we think is true today will maintain its integrity tomorrow. While certain observed natural phenomenon may seem near empirical, based on current scientific evidence, the specifics of each notion will always be altered, for our tools and methods of analysis are always changing and hopefully improving. In the words of C.J. Kaiser, absolute certainty is a privilege of uneducated minds and fanatics. A cursory glance at widely defended historical notions, from the earth being flat to the sun revolving around the earth, teaches us that intellectual change is constant, and in turn humans must keep as open a mind as possible to new information, even if it challenges that person's sense of identity. Everything we think and know are only probabilities, and with modern methods of analysis which have proven to have proactive benefits to society over long periods of time, we can now weigh our understandings and beliefs on an evolving, sliding scale, ranging from least probable to most probable. This is based not on human opinion or subjectivity, but on concrete feedback responses from the natural world. And this point brings us to the scientific method. Nature itself has its own set of rules, and it doesn't have the capacity to recognize or care about what you or anyone else wants to believe is true. Given this reality, it is in our best interest to learn and align with nature as best we can. The best known method for the discovery and application of the laws of nature is termed the scientific method. The scientific method basically has 3 steps: recognizing a new idea or problem that needs to be solved, the use of logical reasoning to create a hypothesis, considering all information available, and the testing of that hypothesis in the physical world through observation. The scientific method of inquiry is what has allowed the human species to gain comprehension of themselves and the physical world. For better or for worse, it is what's behind virtually every advancement that has improved the lives of the human species. However, most in our romanticized world still tend to view science as a cold, heartless medium, while citing distorted human value abominations such as the atomic bomb in refutation of the scientific perspective. In reality, science and technology are only tools, and like anything else, they can be used for productive or destructive purposes. That is our choice. Dynamic equilibrium. A dynamic equilibrium occurs when 2 or more opposing processes proceed at the same rate. There is an equilibrium that exists in the physical world which dictates on some level what the possibilities are for those organisms that utilize the available resources for survival. With respect to our planet, we would call this the carrying capacity of the Earth. The human management of dynamic equilibrium on this planet, which is the most important initial variable regarding the management of society itself, can only come from first understanding what the carrying capacity of the Earth actually is. The needs of the human population must be in balance with the resources of the planet. That being said, let's now examine what we know or can infer about the planetary resources available. The fundamental building blocks of society consist of the following: energy, industrial and technological raw materials, food, air, and water. Energy is the cornerstone of society today. It is one of the most critical factors to all social functionality. The age of oil and fossil fuels, along with all the resulting pollution, is coming to a close. There is no reason to burn fossil fuels at all anymore, other than the profit-oriented vested interest that keeps new clean energy prospects at bay. Remember, the last thing the energy industry wants is abundance, for that translates into a loss of profit in the monetary system. One of the most important sources of energy to recognize today is geothermal power. According to a 2006 MIT report, about 2,000 zettajoules of power is currently tappable worldwide. The total energy consumption of all the countries on the planet is only half of a zettajoule a year. This means about 4,000 years of planetary power could be harnessed immediately in this medium alone. As far as wind energy, a 2005 Stanford University study published in the Journal of Geophysical Research found that if only 20% of the wind potential on the planet was harnessed, it would cover all the world's energy needs. As far as solar energy, the sun's radiation striking the Earth's surface each year is more than 10,000 times the world's annual energy usage. From simple photovoltaic panels that can capture energy into storage batteries for private use, to full-scale solar power plants, new technology is constantly emerging, which is vastly improving this potential. Lesser known is tidal power, which is derived from tidal shifts in the ocean. Installing turbines which capture this movement generates energy. In the United Kingdom, 42 sites are currently noted as available, forecasting that 34% of all of the UK's energy could come from tidal power alone. However, more effectively, wave power, which extracts energy from the surface motions of the ocean, is estimated to have a global potential of up to 80,000 terawatt-hours a year. This means that 50% of the entire planet's energy usage could be produced from this single medium. In view of all of these options, energy is nothing but abundant on this planet. The only reason people today think it might be scarce is because of the monetary system's strategic propensity to create the scarcity. The next question is, what about industrial raw materials? Can the Earth's supply of raw physical materials such as wood, iron ore, aluminum, and such support the needs of the world's population? Global mineral reserves are currently measured by commercial output production. Sadly, this does not give a clear picture of what is actually available. While some elements and minerals are vast in abundance, such as silicon, aluminum, and iron, others are seemingly growing scarce, such as copper, lead, zinc, gold, and silver. As far as we know, there has never been a complete geological survey of the Earth's minerals and elements, only regional ones. This must be done in the future for us to have an understanding of the dynamic equilibrium inherent. Regardless, there are basically three components to understanding the carrying capacity of the Earth. Knowing exactly what the Earth has as far as component elements and materials, where technology is in regard to creating synthetic substitutions for certain elements and materials, and how society organizes and manages its use of these resources. The first thing we need to do is have a full survey of all of the planetary resources. This will give us key information on how to proceed with our operations. For example, if we have an acre of land that we want to grow food with, the first thing would be to test the soil to understand what type of propensities it has. This information would have a direct relationship to what can be grown. This would illuminate the carrying capacity of the land, so to speak. In regard to scarce materials, finding substitutions is always an important pursuit. Many scarce industrial materials today now have synthetic counterparts, and the focus of scientific problem solving in this regard is very important. With this understood, we should realize that the scarcity of most raw materials are only as relevant as the amount of work being invested into finding a substitute or workaround. More important than substitutes and workarounds is the very nature of our usage of the planetary resources. Production output in the world today is staggering compared to the past. With the use of technology, we are able to produce more with far less people faster than any other time in history. However, due to the profit system, there are tons of manufacturers producing the same things as they compete for market share. As noted before, the world's people function within a monetary system that rewards scarcity, planned obsolescence, waste, pollution, and multiplicity. The true cause of scarcity on the planet has less to do with the available resources and more to do with our wasteful and exploitive modes of conduct. Virtually no regard is given to conservation or strategic use until it is too late. In a saner society, the raw materials of the planet would be assessed, industry would be organized as a whole to produce in relationship to what was available, and each item produced would be designed to last as long as possible, causing reduced industrial output and hence resource preservation. Now, when it comes to food production and water preservation, the same monetary system problems of pollution, cost-cutting processes, and scarcity come into play. Water covers 70% of the Earth's surface. Technological advancements such as desalination processes can make fresh drinking water both from seawater and even brackish sources using reverse osmosis. This is yet another example of how technology is just as much a part of resource management as resources themselves. The idea that usable water is scarce is true only in relationship to the limited methods we are currently using, coupled, of course, with the gross industrial pollution that goes on daily.